Let me get this recording going. Okay, so we are going to find some half angles. So take a look at this first, and we have the cosine of 75. Does 75 exist on the unit circle? No, it's not an actual point. It's technically there, right? But it's not an actual, like, really nice point that we use our nice triangles for. And so one way that we did cosine of 75 was using sum or difference, right? And you could say cosine of 45 plus 30, right? That was an option. And so you could use that formula to figure out the cosine of 75. What I'm going to show you today is another formula that you could use, all right? 75 is exactly half of what angle? What angle cut in half is 75? No, don't cut 75 in half. 75 is half of what? 150, yeah. So another way to say this is we could find the cosine of 150 cut in half, right? Because 150 divided by 2 is the same as 75. And so we can use one of our half angle identities to help us out here. We're going to use the one with the cosine, all right? And so we're going to use this plus or minus square root of 1 plus the cosine of u. In this case, u is the 150, and then all over 2. And so let's go ahead and set this up. So we're going to have a big square root. We'll have 1 plus the cosine of 150 all over 2. And that plus or minus, it's not a normal plus or minus like it's both, okay? Because the cosine of 75 is either plus or it is minus. It is not both, right? It's only one or the other. And so one way that these might trip you up a little bit is you have to decide, is it the positive or is it the negative? You have to pick, all right? So all the other formulas before, whatever it was, plus or minus, just came out in the formula itself. But unfortunately, with the sine and the cosine, you have to decide. So it's all based off of the cosine of 75. Where is 75 at? What quadrant is 75 in? The first quadrant. And in the first quadrant, is cosine positive or negative? Positive. So on the plus or minus, you are picking the positive. If the cosine was in the second quadrant, where cosine is negative, then you would have to put in a negative. So it's all about the value that you're picking. It's not about the 150, it's about the 75. All right, are you ready for the simplifying? Technically, we've used the formula. Technically. Now we're on the simplifying. All right, what is the cosine of 150? Cosine of 150? No, cosine of 150, not 180. Negative square root of 3 over 2. And then that's all over 2 still, right? All right, and we can simplify this. Right now, there's 2 square roots, there's a fraction inside of a bigger fraction, there's a bunch of stuff going on. And so whenever you have fractions inside of big fractions, eventually you're going to want to flip and multiply. Before you can flip and multiply, you should take that numerator and get a common denominator, right? And put those together into one big fraction. So in just the numerator, I need to change the 1 so it's something over 2. So what over 2 is the same as 1? 2 over 2. And then that way, we can put that together. 2 minus the square root of 3 all over 2. And that is just the numerator here. And so that's still all over 2. And that is still in a square root. And now you have a fraction in a fraction, right? One fraction in a fraction. And so we're going to go ahead and take care of this big divide by 2 by flipping and multiplying. So this 2 right here is technically 2 over 1. Flip it and multiply. So it become times by a half, right? Let it move up, times by a half. And so we still have that big square root. We still have the 2 minus square root of 3 in the top. And then in the bottom, we'll have 2 times 2, which is 4. And then there's one more thing we can do to simplify this. What? The 2 and the 4, you're saying? You can't simplify the 2 and the 4. Does anybody know why?
Because 2 minus.
Yeah, it's a minus, right? If it was a multiply, simplify away, right? But in the minus world, it doesn't work that way. It'd be 2 divided by 4 and the square root of 3 divided by 4. You'd have to give the 4 to both. So you can't simplify with the 2 unless you could also simplify with the square root portion.
Yeah. I'm thinking if you took out the 2 out of the square root of it, in Taiwan.
Take the 2 out of the square root.
Not 2. I mean the 4. Take out that B2.
Yeah.
Because the square root of 2 minus square root of 3 divided by just 2.
Right, so whenever you have a square root of a fraction, remember you can take the square root of the top and the square root of the bottom. Just like you can square the top and square the bottom, you can square root the top and square root the bottom. So the top is the square root, and then inside is the 2 minus the square root of 3. And that square root of 3 is a square root inside of a square root.
Which is kind of weird.
Yeah, kind of weird. But then the square root of 4 is just equal to 2. And so that denominator of 2 comes out of the square root, which technically is what we need to do because of rationalizing, right? You can't leave a square root in the denominator. So technically all over 2. So the cosine of 75 is equal to this value. How could we check? Because we talked about it briefly, right? How to check. Do you want to grab a calculator real fast so you can check? Humor me, because you might want to check on your quiz or check on your test, right? You can't just give me the decimal answer, but you can check to see if you got it right or wrong.
Yeah. Do you see the decimal answer or the other decimal answer?
So in your calculator, make sure you're in the mode, right? Because this is 75 degrees. So you first have to make sure you're in degrees. So mode, put it in degrees.
Okay.
And then just type in the cosine of 75. And it's going to spit out a decimal.
0.258819.
0.258819. Did everybody get that? Everybody good there? Yes? All right. Now the fun part. You get to put this in your calculator. So how do you put the fraction? Because there's a big fraction in there. Alpha y equals. Put a square root in the top. 2 minus. And then make sure that the next square root is still underneath of the first square root, right? So don't hit the over key because the over key is going to take it out of the square root. And that whole thing, the 2 minus square root of 3, is in that square root. And then the bottom, there is just a 2. And if you hit enter, you also get 0.258819, which is the exact same decimal that we got before. So this is the exact value of the cosine of 75. And that decimal is a decimal approximation. By the way, that decimal goes on forever, ever, and ever, and never, ever repeats. So if I ask you for the cosine of 75 on a quiz or test, and you tell me 0.2588, the answer is really right? I want to see the exact value of what's going on there. All right. How do you feel so far? We all right? See what I mean by, hey, the actual formula itself is not bad, but all the simplifying that comes from it?
Yeah.
That's where we get a hot mess at, right? All right, sine of 15. Before, we could do this with a sum/difference, and we could say 15 was 45 minus 30, right?
Good.
And you could use one of the sum or difference formulas to figure it out. Now we're going to use an angle cut in half. So what angle gets cut in half for 15? 30. So this is the sine of 30 over 2. So when we use our cut in half formula, or half angle, the angle we're going to look at is the 30 degrees. All right, this one also is a big square root. And it's 1 minus the cosine of 30 all over 2. And then before we move on, we're going to decide positive or negative. So sine of 15. The angle 15 is in what quadrant? Q1. Is sine positive or negative in Q1? It's positive, so we're good to go ahead and leave this as a positive. So no negative needed at all. Now on to the fun simplifying. All right. Cosine of 30. Square root of 3 over 2? That'd be so much nicer if it was a half, wouldn't it? Yeah. Yeah, it really would be a lot nicer. All right, so we have 1 minus square root of 3 over 2 all over 2, all inside a square root. The good news is we've seen this before, haven't we?
Yeah.
Isn't this the exact same as the last problem?
Almost.
Almost. No, it's the exact same, isn't it?
Besides minus.
No, the minus. Minus and everything, look.
Oh, yeah.
Right here. It was exactly the same, wasn't it? Yeah, so guess what? We already know what this simplifies to. It simplifies to our final answer from the last problem. So if you already know, you can go ahead and jump there. I'm okay with that. All over 2. Does anybody know why they're exactly the same? Cosine of 75 and the sine of 15. Why they're exactly the same?
I think those reciprocals.
They're not reciprocals. We have talked about why they're exactly the same. Anybody remember?
Because it's the other side of the line, right? The 30's here and the 50's there, so they have the same numbers, but the number is different.
Don't focus on the 30 and the 50. Focus on the 75 and the 15. Because this is the value of the sine of 15. And the other one's the value for the cosine of 75.
So you just sound like 90.
Because 75 plus 15 adds up to be 90. And that's what we call... It's on that orange sheet. Co-function identity. Yeah, that's a co-function identity. That if sine and cosine are the same value, whatever those angles were, they had to add up to 90. And so these are co-function. Exactly. It's just not like 30 and 60 being co-function. It's 15 and 75 being co-function. So if you catch that that's a co-function, you'd be like, hey, I already know that the cosine of 75 is this. We're talking sine, co-function identity. This one has to be exactly the same. Yeah. So technically you have 3 ways now to find the sine of 15. Co-function, sum or difference, and a half angle identity. All right, moving on to the trusty radians. This is the tangent of 5 pi over 12. So we need to figure out what angle got cut in half to get 5 pi over 12. Cutting something in half for 5 pi over 12.
That's 5 pi, or no. Yeah, 5 pi over 6.
5 pi over 6 got cut in half because 5 pi over 6 means that you have a sixth, right? You have 5 of the 6th. And if you take 6 and cut them in half, you'll end up with 12, right? If you have like 6 pieces of pizza and you cut them in half, you'll end up with 12. So essentially, you can just take that denominator and times it by 2, and that'll work every time. So tangent 5 pi over 6 all over 2. So let's use the tangent formula. The nice thing about the tangent formula is that it does not have a plus or minus, right? Which means that we don't have to decide. It's going to be built into the formula, and it'll just come out as plus or minus accordingly. So this will be 1 minus the cosine of 5 pi over 6. Over 6. God, my board has decided it doesn't want to work anymore. And then all over the sine of 5 pi over 6. And by the way, I know that tangent has 2 things that it could equal, right? I pretty much always use this one. Does anybody know why I use that one versus the other one?
Is it because there's the denominator is only one?
Yes, because the plus or minus is not in the denominator. It lives in the numerator. And that actually makes life a lot easier. So definitely on the flipping and multiplying, it makes it a lot easier. All right, so let's go ahead and fill in what we have. Cosine of 5 pi over 6.
Negative square root of 3 over 2.
Yeah, negative square root of 3 over 2. But I already have a negative, so this is going to turn into a positive square root of 3 over 2. So 1 plus the square root of 3 over 2 all over the sine of 5 pi over 6, which is a half. And we do have to simplify this. And the nice thing is it simplifies literally the same way all the rest of them have pretty much. So take care of the numerator first, right? Add those together, get one fraction. So this 1 will become 2 over 2. And so what we'll have in the numerator is 2 plus the square root of 3, all over 2. And then the denominator you still have over a half, right? Over a half. And the whole goal of putting those together was so you could flip and multiply. So you're going to take the 1/2, flip it around, 2 over 1, and multiply. What's going to happen on the multiplication? The 2's are going to simplify, right? So the 2's are gone. This 1 over here in the denominator, that's literally not doing anything because we're timesing by divide by 1, which times or divide by 1 doesn't do anything. So this just is 2 plus the square root of 3. And let's check it to make sure we're right. So I want to do the tangent of 5 pi over 12. Now, one thing I have to do is I have to change the mode. So hit mode, go back to radians. Then tangent 5 pi over 12. Do y'all know where the pi button is?
Mm-hmm.
You know that it's got the plus, minus, times, multiply, and then you have that arrow caret button to get to the power. Well, pi you can use right above it. So just hit the blue button first, and it'll put in pi. You don't want to do like 3.14 because that's an approximation. So if you don't do pi like with the pi button, you should go like 3.14159 something. Try to take as many as you can. All right, I get 3.732. So let's check 2 plus the square root of 3 and make sure that's the exact same number. And I get the same thing, yes? Yeah, so that's one way that we can check to make sure we got it. Now, if on your paper you just said that the answer is 3.732, whatever, I'm not going to give you any points for that. I could teach the freshmen how to do that, right? How to type in their calculator. Yeah, we're not about that. Exact answer, so exact value. All right, let's try another. Cosine 5 pi over 8. So we could think of this as the cosine of 5 pi over 4 being cut in half. Now, with the sine and the cosine, you have to pay attention to the quadrant, right, to decide if this is plus or minus. And we go based off of the actual cosine of 5 pi over 8. That's what we're trying to find. So 5 pi over 8, what quadrant does 5 pi over 8 live in? The second, because it's just over pi over 2, right? 4 pi over 8 would be pi over 2, so it's just more than pi over 2. And in the second quadrant, is cosine positive or negative? Negative. So this is just going to have a negative in front. So it'll have a negative, square root. Everything else will be exactly the same. So 1 plus cosine of 5 pi over 4. And then that is all over 2. All right, what is the cosine of 5 pi over 4?
Negative square root of 2.
Negative square root of 2 over 2. All right, and then unfortunately we have to do some simplifying, right? All right, the good news is it's the same general way every time. Put the numerator together into one fraction, take the denominator, flip and multiply, and then evaluate with the square root, right? So this 1 we'll write as 2 over 2, which I can now put the numerator together. So it's 2 minus the square root of 2, all over 2. And then that is all over 2. And don't forget that in front of your square root, you do have to have a negative, right? And then the 2 in the bottom will flip and multiply. So we're going to multiply by, instead of 2 over 1, 1 over 2. So we have the negative square root of 2 minus the square root of 2, and that's all over 4. And then last but not least, you can take the square roots, right, of the top and the bottom. So negative square root of 2 minus the square root of 2 all over 2. And that's a lot of 2's in one problem, isn't it?
2 too many.
2 too many. Technically, the square roots are powers of a half, right? And powers of a half are 1 over 2.
Yeah.
There's a lot of 2's. The only things not associated with an actual 2 are the minus and the negative and the division sign, right? Everything else has something to do with it too. All right, like I said before, I think using the actual formula and getting it set up is not the problem. The problem is you're probably going to have is when it comes to the actual simplifying, right? The actual simplifying. So getting all of those things, the fractions together, flipping and multiplying, we've done those things before. We haven't necessarily done them all inside of a square root or all together, but we have done them all. All right. These can also carry into another type of problem. And these are similar to the ones that we did yesterday, where they don't tell us the actual angle. They just want us to figure out the tangent of what happens if we take that angle and cut it in half. And they tell us the sine of the angle, and they tell us where the angle is located, so they give us some information. But they don't actually say, hey, the angle is this or the angle is that, right? So we kind of have to hypothetically, we don't know exactly what theta is. I mean, we could figure it out, right? Sine inverse. Yeah. Could figure it out. But we're just going to use our formulas to figure out the tangent of theta over 2. Now, when you do the tangent, you do not need to know plus or minus, right? So that's kind of nice. So we just know that this is going to be 1 minus the cosine of theta over the sine of theta. And in the question, they tell you the value of the sine of theta, negative 15 over 17. What they don't tell you is the cosine of theta. Can we figure out the cosine of theta? Yes, using a handy dandy triangle, right? Handy dandy triangle. So what quadrant are we in that might help us with our triangle? 270 to 360. That's Q4. Sine is what over what? Opposite over hypotenuse. The negative will go with the opposite because technically that's a y value and it's going down, right, from the x-axis. And then anybody know off their top of the head what the opposite is? 8. It's a Pythagorean triple, yeah. If you don't know, you can use the Pythagorean theorem, right? So if all else fails, Pythagorean theorem. Is the 8 positive or negative? It is positive, right? Because that's, if you think about this is where the origin is, that would be positive x, negative y. All right, so we're good to go ahead and start filling things in. So 1 minus the cosine. Cosine is adjacent over hypotenuse. So 8 over 17. And then over the sine, which is the negative 15 over 17. And since we don't have any square roots, technically you could simplify by just putting it in your calculator, right? We're not going to do that, though, because we're smart. We don't need to do it. But if all else fails, you could, yes? Mm-hmm. All right, the 1, though, we can change to 17 over 17. And if you do the subtraction, you would end up with 9 over 17 over negative 15 over 17. So that's not too bad, right? Nope. And then how would you take care of the fraction in a fraction? Flip and multiply. So this one flips over, it reciprocates, and you're going to multiply. And what's going to happen on the multiplication? Yeah, the 17s are going to simplify themselves out. So this just turns into 9 over negative 15, which does simplify as well, right? 9 over negative 15, which is, oh, what was I writing? 3 over negative 5. And by the way, that negative you can technically put anywhere, right? 3 over negative 5, negative 3 over 5, negative, and then 3 over 5, however you want to put it in the front, in the top, in the bottom. It really doesn't matter. All right.
That's tangent, right?
That's tangent, yes.
And that's also a Pythagorean triple.
Not for tangent, though, because tangent is opposite over adjacent. Yeah. If that was sine or cosine, then yes. Miss Bird? Okay. Daniel, time for you.
Okay. So.
I'm recording it, so I'll send it to you. All right. Let's try another. Tangent, negative 4 over 3. And it says theta is between 270 and 360. Find the cosine of theta over 2. And so for cosine, we do need to figure out if it's plus or minus, right? So we know we're going to have that square root, all that fun stuff, but we need to first figure out plus or minus. So how are you going to tell plus or minus? You need to find out where theta over 2 lives, right? They tell you where theta is. It's between 270 and 360. So where would theta over 2 be? If the biggest theta can be is 360, what's the biggest theta divided by 2 could be? 180. Divide this by 2, and we know that its upper bound has to be 180, which means that what's the lowest it could be? Divide that number by 2, that is 135. So it's between, theta over 2 is between the 135 and the 180. And what quadrant is that in? That's Q2. And in Q2 is cosine positive or negative? It's negative. So as we do this problem, we're going to have a negative in the front. Square root 1 plus cosine of theta all over 2. That's the cosine. And we need the cosine of theta in order to figure this out. We know tangent of theta. By the way, what is cosine of theta not? It is automatically not 3. So everybody cool with that? All right. We talked about that yesterday, right? That tangent is sine over cosine, but tangent's only opposite over adjacent, where sine and cosine are opposite over hypotenuse and adjacent over hypotenuse. So when you do the division, you get rid of the hypotenuse. That does not make it cosine immediately, the denominator. It means that some simplification has happened for it to work out that way. So how can I find the cosine?
Triangle.
Yeah, make yourself a nice triangle. This is all about theta, right? Cosine of theta. So go back to the original theta. So that is technically in Q4. And in Q4, you have opposite over hypotenuse, right? And so it'll be a negative 4, positive 3. And for cosine, you need the adjacent and hypotenuse. So we know 3 over, what's the hypotenuse? 5. 3, 4, 5. So cosine will be 3 over 5. So we're going to throw that into our equation. All over 2. All right, you could use your calculator to help you simplify the inside, right? Just the inside. You could do that. But we're just going to do it by hand. Because practice. Why not, right? All right, so if I have 1 plus 3/5, you can change the 1 to a 5 over 5, which would then make the numerator 8/5, right? All over 2 inside the square root with a negative in the front. Flip and multiply, what's going to happen? The 2 is going to change to 1 over 2, right? Times by half. So it's negative square root of 8 over 10. What's 8 over 10 equal? 4 over 5. And technically, you can also square root 4 and square root 5, right? Okay, if I do those at the same time. Square root of 4/5, which is the square root of 4 over the square root of 5. All right, we're getting closer. Square root of 4 is 2 over the square root of 5, because the square root of 5, that's not a nice number. And unfortunately, you can't leave it, right? You still have to. Yeah, you have to rationalize. So the square root of 5 will move to the top. So negative 2 square root of 5, and then it'll all be over a regular 5. So we had the formula done here in purple, and then all of this was just simplifying. Just all the algebra that goes with it. All right, what do you think? Like I said earlier, the formulas themselves not too crazy, but the simplifying of the formulas, ugh. And if all else fails, you can always just check in your calculator, right, to make sure you got it. This one, not so much. You'd have to get a little more creative when you're checking your calculator, but you could. You could figure out what theta is and then it divided by 2 and then take the cosine of it and make sure it matches. That would work. Not as easy to check in our calculator, though. All right. Let's move on. We're back into radians. Try to do some radians and some degrees examples. All right, so the cosine of theta is 5 over 13. Theta is between 7 pi over 2 and 4 pi. And we need to find the tangent of theta. The best thing about the tangent, though, is you don't have to decide plus or minus, right? It's just, it'll give it to you. So we don't really care much about what's going on here as of right now. So let's go ahead and figure out what this is. So this will be 1 minus the cosine of theta over the sine of theta. And you have the cosine, so you know that's 1 minus 5 over 13, but you don't have the sine. So in order to figure out the sine, you do have to make yourself a triangle, right? By the way, if you don't need a triangle to figure out what the sine is, you don't have to make one. It's not required. But if you're like, I don't know what it is, or you want to just get a nice picture of it, that's fine. By the way, what quadrant is theta in? Because that's just going to help us with pluses and minuses. It is in Q4, right? The easiest way to tell is 4 pi is the same as 2 pi. And so theta comes right before 2 pi. So that has to put it in Q4. Here's theta, our angle. Cosine is adjacent over hypotenuse. So what does that make the opposite? 12? I heard a 12. 5, 12, 13. Is that a Pythagorean theory? Identity triple? Yeah, it is 12. And then technically that 12 is a negative. So when you put it in your equation, it'll be a negative 12 over 13. All right, I'm going to pause and let you simplify that. Get all the way down to a simplified fraction. Give it a shot by hand. See if you can come up with it by hand. Did y'all come up with negative 2/3? Negative 2/3. So the numerator ended up being 13 over 13. So 13 minus 5 is 8. 8 over 13 divided by negative 12 over 13. When you flip and multiply the 13, simplify, right? So it's 8 over negative 12, which simplifies to negative 2 over 3. All right, last example. We have the cosine of theta is negative 3 over 5. And then it tells us where theta lives. And we need to find the cosine of theta over 2. So because we're looking for a cosine here, we do have to decide plus or minus, right? So theta is between pi over 2 and pi. So where would theta over 2 live? Because that's the angle we have to decide if it's plus or minus. Theta over 2 would live between where and where? Pi over 4. So if you cut pi over 2 in half, you would get pi over 4. That's the smallest it can be. And then pi cut in half is pi over 2. Maybe, possibly. Pi over 2. So the biggest it could be is pi over 2. So what quadrant is this in if it's between pi over 4 and pi over 2? Q1, and is cosine positive or negative in Q1? Positive. So this will just be a positive square root. All right, inside the square root for cosine, it's 1 plus the cosine of theta plus cosine theta over 2. And then the really nice thing is when you're looking for a cosine of theta, they actually give it to you, don't they? So we don't have to make ourselves a triangle. We don't need to figure out any other sides. We're good to just go ahead and plug in that value. So 1, and that'd actually be a minus because it's a minus 3/5 over 5 all over 2. All right, and I'm going to let you try to simplify this guy. See how far you can get it. All right, I ended up with square root of 5 over 5 when it's all said and done. So 1 minus 3/5, that was 5 over 5. So 5 minus 3 is 2 over 5, all over 2. Flip and multiply. The 2's will simplify, so it's just 1/5. Square root of a 5th is the square root of 1 over square root of 5. So 1 over square root of 5. Rationalize to square root of 5 over 5. Like I said, simplifying. That's the part that takes the most time, right? All right, questions, comments? How do you feel? Yes. All right, so in terms of your assignment,